So let's talk about the time sharing system. And there's this person on the right, which probably has no relation to what I'm teaching, but it has. Let us consider n processes which may be from one user or multiple users. Doesn't matter. There are n processes, one user or multiple user, doesn't matter. As the name suggests, the time sharing operating system, each process gets a fixed amount of time, and that time is known as quantum, right? Now, once this quantum is over, the operating system hands the computing power to different processes. So basically, in general operating system, let's say if there's one process coming, they may have different things. Basically, if one process is coming in the queue, there's a CPU, it gets the CPU, maybe it fails, maybe it exits, that's fine. But in time sharing, there's one process that requires 10 milliseconds. So it's like, no, I know that you require 10 milliseconds, but there's a quantum that is probably, let's say, 2 milliseconds. I'm going to allow that for every process, max to max. So you come, you get processed for 2 milliseconds, you go back. Go back in the queue. When you will have your turn again, you come back. So this is better for different, even in your computer. So let's say you try to open two files at once, right? So in the case, let's say you are trying to open up a game. Now let's say rather than giving the whole processing or the whole system or the whole processor to load the game, everything else will start working slowly. Let's say you are listening to music, it will start working slowly. No. So it's like, okay, I'll not give you the whole system. I know that you require, let's say, for 1 minute, let's say you require a total of 500 milliseconds of, let's say, computing power or computing time. So I'm not going to give you in the whole go. I'll say that, okay, out of 500 milliseconds, take 5 milliseconds, then go back to the queue, then take 5 milliseconds, go back to the queue, then take 5 milliseconds, go back to the queue, right? In some cases, let's say this is rather than 10 milliseconds, this is 110 to the power of 6 milliseconds. So in some versions, it will have different quantum queues. So let's say this is 2 milliseconds. So in that case, it will say that, okay, I have 10 to the power of 5 milliseconds queue. Probably this is more suited for you to go to that. So, there could be parallel quantums as well, right? So basically this guy is Paul Rudd. Basically, he's kind of an expert in quantum mechanics. So let's move ahead. With the time sharing concept of multitasking system has also arrived. Consider an example on the, I've given the same example. On the personal computer, you're listening to music as well, and you're trying to open a Google document locally. Now, in the case of traditional system, the file has some error and the file is not able to open, the system may get blocked. Now, even your MP3 file that you're listening music to may also stop because there's a failure. But in the time sharing system, the computer tries to open your erroneous Google document for a quantum of time. Once this quantum of time is complete, the computing power is given back to the audio player for its own quantum and the computing which is required for the music to play for the next few seconds. So it's like, okay, I give you the process, maybe for the next 10 seconds, your music will play. Probably at that point in time, you will come back, you will get your execution. So again, the next 10 seconds will play. And then the system may try to open your Google document again. This keeps on executing till the time computer decides after multiple tries and giving multiple quantum amount of time that the file will not open. So let's say there's an erroneous file. It will not open, I know for sure. But the CPU does not. So it will give you quantum of time again. It will not execute every time it gives, it fails. So it will not give the time after a certain tries. Let's say 10 tries it gives, it's not happening, then it's like, okay, you will not open, let me give you error. Or so those kind of things. So in the next video, we'll talk about the network system. Thank you so much.